Hello and welcome to a lesson on trigonometric ratios and special angles. Now, a bit of this is going to be a review from grade 11. Um, the major difference between this lesson and lessons that you've had in the past on trig ratios is that all the angles are now going to be in radians. Now, recall that we used two special triangles to find exact values of sine, cosine, and tangent for angles 30 degrees, 45 degrees, and 60 degrees. So now what we have to do is we need to convert these to radians. Now we have done a bit of this already. We have been converting to radians. So 30 degrees, in order for us to convert it to radians, we would have to multiply it by pi over 180 degrees. And so what that's going to reduce to is pi over 6. Now 45 degrees is going to be pi over 4. Okay, so 45 times pi over 180. And then lastly, 60 degrees is pi over 3. Okay, so you're going to need to memorize these three angles in radians. Now, how do we switch calculators to radians? So this is important. You have to be able to do this. Otherwise, the ratios that you're going to get for certain angles, or if you're trying to find an angle and you use the, let's say, the inverse of sine or cosine or tangent, your calculator has to be set in radians if we're working with radians. So depending on what kind of calculator you have, if you have a sharp calculator, then you have to press second function and then DRG. DRG is towards the bottom of the calculator, and that will allow you to set your calculator to either radians or back to degrees. And then after pressing second function DRG, you would have to then, I think you have to press equals. Now on a Casio calculator, you would have to press mode, okay, and then it's either mode or shift mode, and then you'll be able to change from degrees to radians, or you could go back to degrees if you ever need to. Okay, so let's review the special triangles. So there are two of them. And what I'm going to do is I'm going to now use radians instead of degrees. So at the top here we have 30, so I was about to write 30 degrees, but so 30 degrees is pi over 6. Pi over 6 radians. Bottom right we have 60 degrees, which we now know is pi over 3 radians. And then 90 degrees is pi over 2 radians. Okay, now to label the actual side lengths. So the longest, well, this is actually not the longest. The second longest after the hypotenuse, side length is root 3. The hypotenuse, which is opposite to the 90-degree angle, is 2. And then the shortest side length is equal to 1. Okay, so 1, root 3, 2 are the side lengths of the first special triangle. Now the second special triangle has pi over 4. So that's 45 degrees. So it's an isosceles triangle. So it has two equal side lengths and two equal angles. So 45 and 45 are pi over 4 and pi over 4. And 90 degrees as well, so pi over 2. So both of these are right triangles. Side lengths are 1, 1, and root 2. Now you might remember that in grade 11 you actually derived these triangles, right? So we're not going to do that again. But if you still have your notes from grade 11, then you can check back at and look at how these are actually, where we get these special triangles from and how they're derived. Um, okay, so in addition to special triangles, there are some key radian measures to remember. So starting with 0 radians or 0 degrees, and also 2 pi. Now, what I'm actually going to do here is I'm actually going to write that. I'm going to write that here. Okay, and now 30 degrees, we already know is pi over 6. 60 degrees, or well, 45 degrees is pi over 4. 60 degrees is pi over 3. And then 90 degrees is pi over 2. Okay, and then we continue this on. And we have 2 pi over 3. Okay, then we have 3 pi over 4. So 2 pi over 3, that's 120 degrees. 3 pi over 4 is 135 degrees. And then we have 150, so that would be 5 pi over 6. And then here we have pi. Okay, continuing on, we have 7 pi over 6. So that would be 210 degrees. Then we have 4 pi over 3. So that, or not 4 pi over, that's, so this would be 5, yeah, 5 pi, yeah, 5 pi over 4. That's 225, and then here we have 4 pi over 3, it's this angle here. Then here we have 270, so 270 is 3 pi over 2. That's 370. Continuing on here, we have 5 pi over 3. Okay, so that's 300 degrees. Then 7 pi over 4. That's 315 degrees. And then we have 11 pi over 6. So that's 330 degrees. Now, what I'm also going to put on this triangle, and you may have learned this before, are the actual ratios for the terminal arm. Okay, so recall that these ratios, the way they work, so for the first one, it's basically cosine of 30, or cosine of pi over 6. So cosine of pi over 6 is root 3 over 2. And sine of pi over 6, or sine of 30, is 1 over 2. So that would basically be this point over here on the circle, on the unit circle. So what we're looking at here is a unit circle, so the radius of this circle is 1 unit. Okay, so then this next point over here is root 2 over 2 and root 2 over 2. So the x and y values of the point. Then going on to the next point on the unit circle. So cosine of pi over 3 and sine of pi over 3. So that's 1 over 2. So that's cosine of pi over 3. And root 3 over 2. That would be sine of pi over 3. Now on to this point over here. This point is actually very easy, very straightforward, the one at pi over 2. So since this is a unit circle, this point is just 0 and 1. Okay, it's basically the y-intercept of the circle. Okay, moving on. So in the second quadrant, cosine ratios are going to be negative. So we're now going to have negative 1/2 and root 3 over 2. So sine ratios are positive in the second quadrant. Now for 3 pi over 4, so 135, negative root 2 over 2 and root 2 over 2. And then for 5 pi over 6, so cosine of it is going to be negative root 3 over 2. And sine of 5 pi over 6 is going to be positive 1 over 2. Now on to pi, or 180 degrees. So remember, this is a unit circle. So we're at negative 1 for x and 0 for y. Moving on to 7 pi over 6. So this point is going to be, so related acute angle here is pi over 6. So both sine and cosine are negative in quadrant 3. So negative root 3 over 2, comma, negative 1 over 2. 5 pi over 4, negative root 2 over 2, and negative root 2 over 2. So recall both sine and cosine ratios are negative in the third quadrant. Okay, 4 pi over 3. So that is going to be negative 1 over 2 and negative root 3 over 2. Now we're at the bottom of the circle here, which is the second y-intercept here. So that's going to be at 0 and negative 1, telling us that cosine of 3 pi over 2 is 0 and sine of 3 pi over 2 is negative 1. Okay, now for 5 pi over 3. So cosine is positive in the fourth quadrant. So 1/2. Sine is negative. Negative root 3 over 2. Okay. And now for 7 pi over 4. So root 2 over 2 and negative root 2 over 2. Okay. And then the next point over. So this is now for 11 pi over 6. Negative 1, negative, actually positive, not negative. So positive, so this is going to be root 3 over 2 and negative 1 over 2 for sine of 11 pi over 6. Then lastly, that brings us to this last point over here, which is at 1 and 0. It's an x-intercept of the circle. Okay, so this is a good diagram to refer to. It shows all the ratios for sine and cosine, and also all the angles, all the special angles in radians. Okay, so now instead of solving for trigonometric expressions and equations in degrees, we can solve using radians. So in general, to find trig ratios for angles greater than 90, so recall that 90 is what? It's pi over 2. You need to find the related acute angles, also known as the reference angles. The related acute angle is the angle formed by the terminal arm of an angle in standard position and the x-axis. Okay, so let's try to evaluate these. We're going to try to find the exact values of sine of 4 pi over 3 and cosine of 4 pi over 3. So what we need to do first is we need to sketch the angle. So 4 pi over 3 is slightly bigger than pi. It's slightly bigger than 3 pi over 3. So 3 pi over 3 is pi, which is 180 degrees. So basically, if we take 3 pi over 3, and we add pi over 3 to it, we get 4 pi over 3. So that tells us that we are here. Okay, so we are in quadrant 3. Okay, and so this is the principal angle here. Okay, so that's the principal angle. And we're going to find the related acute angle. Okay, so in order to find the related acute angle, which I'm going to call theta r, I'm going to take 4 pi over 3 and just subtract pi from it. So 4 pi over 3 minus 3 pi over 3 is just pi over 3. Okay, so the related acute angle is pi over 3, which is 60 degrees. So what I'm going to do now is I'm going to label the sides of the special triangle, because this is a special angle. And so what I know is that this is going to be -1, the adjacent side to the related angle. The opposite side is going to be -√3. And the hypotenuse is 2. Now, the adjacent side is negative and the opposite side is negative because both sine and cosine ratios are negative. And also x is negative in the third quadrant, and y is negative in the third quadrant. So now having that, we're now able to evaluate. So sine of 4 pi over 3, okay, is going to equal, if we look at what we have here, we're using the related acute angle, so opposite over hypotenuse, -√3, that's the opposite side, over 2. Okay, so -√3 over 2 is what sine of 4 pi over 3 is equal to. All right, let's now also try to figure out what cosine of 4 pi over 3 is going to equal. Okay, so 4 pi over 3, what it is, it's basically pi, which is 180, and then we're adding 60 to it, right? So that's going to be 240 degrees if you convert to degrees. So cosine of 4 pi over 3, okay, so adjacent over hypotenuse. So adjacent is -1, and the hypotenuse is 2. So -1 over 2. Now you can also write the negative in front of the fraction if you like, if you prefer to do that. Okay, let's go on to writing 6 trigonometric ratios for 11 pi over 6. Now 11 pi over 6 is very close to 12 pi over 6. And 12 pi over 6 is 2 pi. Okay, so one way of kind of figuring out what the related acute angle is what you could do is you could take 2 pi and take away 11 pi over 6. That's one way of doing it. Or you could just kind of see that, well, it has to be pi over 6 because if 2 pi is 12 pi over 6, then 11 pi over 6 is just, if you take away pi over 6 from 12 pi over 6, you end up with 11 pi over 6. So the related acute angle is going to have to be pi over 6. And so the principal angle is that. And so drawing the terminal arm here, okay, so that's what the terminal arm is going to look like. And then remember, you always draw towards the x-axis, never towards the y-axis when you're constructing the right triangle. So now labeling these, so this is a special triangle. So the adjacent side is going to be positive because x values are positive in the fourth quadrant, and it's root 3. Opposite side here is going to be -1 because y values are negative in the fourth quadrant, and then the hypotenuse is 2. Now the hypotenuse is always positive. The length of the terminal arm is always positive because it's a length. Length can be negative. So now that we have that, we're ready to figure out the different ratios. We just need the special triangle. So sine of 11 pi over 6. So the related acute angle is pi over 6. Okay. So opposite over hypotenuse. -1 over 2. Then we go on to cosine of 11 pi over 6. And so that's adjacent over hypotenuse. So root 3 over 2. Then tangent of 11 pi over 6. So opposite over adjacent, -1 over root 3. Now it would be a good idea to rationalize this because you don't want to have a radical in the denominator. So negative root 3 over 3. Now we go on to the reciprocal trig ratios or the secondary trig ratios. So reciprocal of sine is cosecant. So cosecant 11 pi over 6, we're just going to reciprocate sine. So it's going to be -2. Reciprocal of cosine is secant. Secant 11 pi over 6. That's just the reciprocal of cosine, so that's going to be 2 over root 3. When we rationalize that, we multiply the top and bottom by root 3. And that's going to give us 2 root 3 over 3. And then lastly, cotangent of 11 pi over 6 is the reciprocal of tangent. So that's just going to be negative root 3. Okay, so going on to example 3. So sine of pi over 2. So first we draw where this is. Okay, so it's here, the terminal arm, 90 degrees, pi over 2. Now, one thing that we kind of know about this is that here, this point, if you look at the unit circle from before, right, the point here is 0 and 1. Okay. Now, one thing that we can kind of talk about briefly here is that normally when you have a terminal arm in standard position, the hypotenuse is r, the adjacent side to the angle theta is x, and the opposite side is y. So that means that sine of angle theta is opposite which is y, over r, the hypotenuse. Now in this situation, since we're dealing with a unit circle, a circle that has a radius of 1, r is going to be 1. Y is also going to be 1. However, x is going to be 0. Now, if we use this definition that sine theta is equal to y over r, that means that sine of pi over 2 is going to equal, so 1 for y, over 1. So y is 1 and r is 1. Okay, since we are dealing with, this is a circle, right? This is a unit circle. Okay, so that means that sine of pi over 2 is just equal to 1. And you might remember that from grade 11, that sine of 90 is equal to 1. All right, let's have a look at example 4. Find the exact values for cotangent 5 pi over 4 plus tangent 11 pi over 6 multiplied by tangent of 5 pi over 3. Okay, so it's a good idea to draw these out. Okay, so 5 pi over 4, you might remember that 5 pi over 4 is here. It's in the third quadrant. It's 225 degrees. Okay, so that's 5 pi over 4. Now the related acute angle is pi over 4. So this would be negative 1. That would also be negative 1. And then this is going to be root 2. Okay, now for 11 pi over 6, so also draw that. So we know that 11 pi over 6 is 330. Related acute angle is 30, or pi over 6. Okay, so 30, so pi over 6. Okay, that's 11 pi over 6. And so we label this root 3, negative 1, and 2. Okay, now one more. So 5 pi over 3. Yeah, I'm going to have to definitely shrink this, that's for sure, afterwards. It's taking up too much space. So hopefully you don't draw it too big. So 5 pi over 3, okay, so that's going to be, it's going to be around here. So in the fourth quadrant, related acute angle is pi over 3. Hypotenuse is 2. Negative root 3, opposite side. Adjacent side is 1. Okay, 5 pi over 3. Okay, so now that we have that, so what I'm going to do is I'm going to shrink these. They're a bit too big. Let's shrink this one as well. What happened here? Let's move it. Okay. And then also this one as well. Okay. All right. So now we're gonna refer to them still though. Okay. So let's see what this is going to become. So cotangent is adjacent over opposite, the reciprocal of tangent. So adjacent over opposite. So that's just going to be 1, right? Negative 1 over negative 1 over negative 1. Okay. Plus tangent of 11 pi over 6. Okay. So that is opposite over adjacent. So that's going to be negative 1 over root 3. Okay. And then multiplied by, okay, so this is being multiplied by tangent. Okay, so tangent of 5 pi over 3. So tangent of 5 pi over 3, opposite over adjacent again. So that's going to be negative root 3 over 1. Okay, so this is going to simplify fairly easily. So we got positive 1. So yeah, this is going to become positive because two negatives. So plus, the root 3's cancel out, so just plus 1. So that's just going to equal 2. A pretty simple calculation. 1 plus 1 equals 2. Okay, and so that's what this whole expression is equal to. All right, moving on to example 5. So if negative 2 and negative 3 lies on the terminal arm of an angle theta in standard position, determine the exact values of sine theta, cosine theta, and tangent theta. All right, okay. So we want to draw this out first so we can visualize the situation. And so x is negative 2 and y is negative 3. Okay, so we're going to put a point down at negative 2 and negative 3. And we're going to draw the terminal arm. And so that's our terminal arm. Now what we want to do is we want to construct a right triangle and we draw towards the x-axis always. Now our angle, theta, is that angle, this principal angle, that's theta. And what we want to do now is we can label this triangle, right? So we can see that this is negative 3. Okay, and that's negative 2. Now we need to find r. Okay, so in order for us to find r, which is, we'll call that r is the hypotenuse of this triangle, we just have to use Pythagorean theorem. So square root of negative 2 squared plus the square root of negative 3 squared. And so that's going to be 4 plus 9, which is 13. So that's root of 13. Okay, so now we have enough. We have all the side lengths for this triangle. And so we can move on to finding the ratios, the primary trig ratios, starting with sine. So sine theta is going to be opposite over, so recall we are using the related acute angle again. So opposite over hypotenuse, negative 3 is the opposite side length. And then the hypotenuse is root of 13. Now we do want to rationalize this, so we're going to multiply the top and bottom by root of 13, and that is going to give us negative 3 root of 13 over 13. So that's sine of theta. Now moving on to cosine of theta. So that is going to be adjacent over hypotenuse. So negative 2 over root 13. We're also going to rationalize by multiplying the top and bottom by root of 13. And so that's going to be negative 2 root 13 over 13. And now for tangent. Tangent of theta is opposite over adjacent. So negative 3 is the opposite side to the related acute angle over negative 2. So that is going to be positive 3 over 2. It's going to be the ratio for tangent of theta. All right, now finding the angle. So calculate the related acute angle in radians to 2 decimal places. All right. So just a related acute angle in this case, so not even the principal angle. So we can use any of these ratios really, right? So we can use, I think tangent would probably be the easiest one to use here. So if we start with tangent of theta is equal to 3 over 2, right? Recall that in order to find theta, what we do is we just do the inverse operation, right? So this is known as arctan or tangent inverse. So tangent inverse. Now what's important here is that the calculator has to be set to radians for this to work, for you to get an angle in radians. So make sure you set your calculator to radians first, and then you would key in tan inverse of 3 over 2, and that should give you 0.98 radians. Now recall, you don't have to put units for radians. Okay, so 0.98 is the related acute angle. So this is just an angle in the first quadrant, basically. Or, well, it's an acute angle. Okay, now looking at example 6. Now, before we move on to example 6, I just want to mention that if we wanted to find the principal angle, so this is just a related acute angle, right? But let's say we wanted to actually find what the principal angle is, like sort of like a part C to this. Okay, so principal angle. So what we would do is we would take our related acute angle, 0.98, which is in here, and we would just add pi to it, right? So if we wanted to find theta, the actual principal angle, we would take 0.98 and we would add pi to it. And just using a calculator, what is that going to be? So 0.98 plus pi is going to give us 4.12. Okay, so that's what the angle is in radians, this principal angle in the third quadrant for this terminal arm. Okay, so now for the last question. We want to determine two different possible angles in radians if cosine theta equals negative 1 over 2. So the cash rule applies to this a little bit. So recall what the cash rule is. So the cash rule states that in the fourth quadrant, cosine ratios are positive. In the first quadrant, all ratios are positive. In the second quadrant, sine ratios are positive. And in the third quadrant, tangent ratios are positive. So that is the cash rule. Now, since the cosine ratio here is negative, negative 1 over 2, we know that the terminal arm is going to have to be either in quadrant 2 or in quadrant 3. Okay, now by looking at the special triangles, you can kind of figure out what the related acute angle is here. But an easy way to do it, if you really have no idea, is just to do cosine inverse. Make sure you do positive 1/2. Don't put the negative sign. Okay, and so what that will give you is, depending on your calculator might give you it in radians the proper way in terms of pi, or it might give you some decimal value. But what it is that it's pi over 3. That's a related angle here. So that's a related angle. We know that we're going to have a terminal arm here, and we're also going to have a terminal arm here. Okay, now I maybe drew this a little too steep, so let me draw it again. Okay, so those are the two positions. So we draw our triangles. We have one here, and then we have another one here. And so right triangle, right triangle. So we know this is pi over 3. And we also know that this is pi over 3 as well. So based on that, to get our two angles, I'm gonna call the first one theta 1, and then this outer one theta 2. So theta 1, in order to calculate it, we would do pi minus pi over 3, which is 3 pi over 3 minus pi over 3, which is 2 pi over 3. Okay, so that's the first principal angle here. Now the second angle is in the third quadrant. And to get this one, we would take pi, and we would add the related acute angle, pi over 3. So 3 pi over 3 plus pi over 3 is 4 pi over 3. So those are the two possible angles here in radians. Okay, so for homework, you can work on these two questions. Well, each one has multiple parts. And there are also some questions in the textbook. So make sure you refer to the Unit 4 outline for which questions to do from the textbook. Now, also, if you haven't done the warm-up, make sure you also do those questions. Thank you for watching.